welcome to It's Your Water. I'm Michael Urbans. I'm glad you found us. Today's topic is ultrafiltration. Today we'll be talking with Justin Mest of Master Water. They are a leader in the manufacturing of ultrafiltration equipment. The way that Master Water Conditioning has packaged their ultrafiltration is in a unique fiberglass tank with a control valve, and they call it the Ultra Pro. And that packaging has made a big difference, and it's applied across the industry, where before the packaging of it was more like a reverse osmosis system, and it was almost like an erector set in a box. We're not going into an infomercial here, but indeed, it is an extremely well package system that can be applied. Where do we use ultrafiltration? Where's it fit in our treatment train and the most popular applications for it? Because it is an exciting technology that you guys have pretty much developed, packaged.
Yeah, so. And I think the emphasis on the packaging real quick is really important too, because that was, when you look at our Ultra Pro design, everything from the membrane, from the ground up, it was all designed by us, and the concept was we want this to be as familiar to your typical water treatment dealer as possible. Because from the outside, it basically just looks like a backwashing filter, right?
Yeah.
Well, it took a lot of effort to get it there, and that was a very conscious decision from the very beginning. But to actually answer your question about where do we use ultrafiltration, I think it's important to first understand what really is an ultrafilter. And ultrafiltration is an umbrella term, and it's really mainly about a specific range of micron ratings for the membrane, because ultrafilters come in several different shapes and sizes. Generally speaking, ultrafiltration would cover the range of 0.05 to 0.01 micron filtration.
So a human red blood cell's 7 microns, and a human hair is 40 microns. Just to give you, we're way below that. Where viruses hang
we're filtering out stuff that you can't see.
Oh yeah, invisible stuff.
Unless not with the naked eye.
Unless it's extremely concentrated.
But it's important to remember that even though we're talking about things we can't see, we're not talking about dissolved substances. Ultrafiltration, no ultrafilter will remove a dissolved substance. By dissolved substance, we're talking salts. We're talking sodium chloride, calcium chloride, so on and so forth. We're not taking any of those things out. We're taking out suspended contaminants, but it's important to remember that things like bacteria and virus and cysts, even though we can't see them, they are still suspended contaminants.
But nothing ionic. Is what we're saying.
Yeah, nothing
on the ionic scale, like what reverse osmosis would remove, or ion exchanged resins, cation and anion. So, but these are still particulates, but real itty bitty particulates,
really, really tiny. Frankly, the initial marketplace that we were really intending to go after was actually small systems for the surface water treatment rule, because ultrafiltration is an excellent solution for both virus and cyst reduction, which conventional UV systems often don't work super great for. Some UVs have come a long way, and you can get ones that do work for cysts now, but cysts essentially, they protect themselves. They have an outer shell, so to speak, that protects them from things like chlorine oxidation and UV.
Like cryptosporidium that this speaker got in Guatemala on a fishing trip. I call them the cockroach of bacteria. They can live anywhere, and they can actually live dry, from what I understand, and recolonize. Yeah, that was not pleasant, folks.
Legionella is another classic example. That's when I'm talking about cysts. Those are the kinds of things I'm talking about. So it can be hard to kill them with traditional technologies like chlorine and UV. It's arguably often more effective to physically remove them with something like ultrafiltration. Plus, ultrafiltration, like we mentioned, will also reduce bacteria. So in addition to small water systems, we were also really looking, and this is a marketplace that frankly very few people have really tapped into, city water applications. We talked about Flint briefly earlier, but there are also, boil water warnings are becoming more and more common. Why? Because of failing infrastructure. And that's a billions, and we're talking billions of dollars to fix an infrastructure issue. That ain't happening anytime soon. So there are a lot of people that are concerned about the health, the sustained health, I'll say, of their municipal water. And municipal water treatment plants do an excellent job, but they can't help the fact that the good water they're sending our way has to go through bad pipe.
Or a broken pipe,
Yeah.
or,
And when there's a pipe break, you can get bacterial contamination.
and that's one thing I tell people is with we talked earlier about a reverse osmosis, and we were just kind of geeking out about it, is that, okay, you come downstairs in your slippers, you got your cereal bowl, and you turn on the TV and Action News, and you look and it says, there's a boil water alert in Pottstown. And you look and you say, I live in Pottstown. I just drank half a glass or 2 glasses of water and didn't boil it. But however, if you had, a reverse osmosis or a ultrafiltration, you would have been okay for that instance, that if you forgot or that people don't know about boil water alerts until they turn on the news, is what I'm saying.
Yeah. And they don't have to immediately let you know legally. There's a sort of a lag period too. So,
Sure.
which is reasonable because a municipality can't be expected to immediately tell you.
No, and we're not bashing municipal water here, but it's just, again, it was a tool in a toolbox, but I found as part of a comprehensive treatment system that you can value add a ultrafilter at the very end, and you could comfortably say that you're truly protected as far as it's maintained and in working order. Your protection better than any of your neighbors would be,
Well, and part of the beauty of ultrafiltration too is, I mentioned UV earlier, and UVs are obviously very common. A lot of people out there probably thinking, well, why can't I just put in a UV to do the same thing? Well, the advantage of a UF is a UV requires electricity, right? So what if there's a main break and you lose power?
Right, of course. It's UV is only good. Plus,
ultrafiltration doesn't require electricity. Ultrafiltration will protect you even when the power is out. Now, if your power is out for 2 weeks, your membrane may get fouled.
Yeah,
but the point is, it's still going to take out the bacteria. That's something really important. So if you have a customer that is on city water and they're just concerned and they just want protection against things like boil water alerts and recontamination events of any of that nature, really the best option for them is ultrafiltration, because they get 24/7 protection with or without electricity.
So if you're a doomsday prepper, call us.
Yeah.
But this is how universally applied that the ultrafiltration, most of the ones that we've sold to our customers are typically extreme problem water.
Like colloidal clay.
Colloidal clay.
Colloidal clay is what we actually sell. Like I mentioned earlier, the target markets were what I just talked about. Where we actually use them the most is for colloidal contaminants, whether it's clays, silts,
and this is
some
water.
Organics.
Yeah, this is the water. If you got a nice clear jar of water and say, a spring water bottle, and you pour your water in there and it's nice and murky, very murky, and you look at that, and a week later, it's still murky. Only maybe a little bit is settled out. You have colloidal clay. And that's where these really, really shine, properly sized and properly applied. They are just unbelievable. There are different things that do challenge the membranes. Iron is one of them. But that typically is a good application for the ultrafilters. The really, really murky water that doesn't settle out rapidly. Usually sediments will settle out to the bottom of a water sample jar fairly quickly. In 24 hours, the water look clear, but you got a whole bunch of mud on the bottom of the jar. That's not what we're talking about. We're talking about the stuff that stays suspended. And where we also apply it is where people used alum to precipitate. You're growing it and then precipitating with a chemical. You grow the particle and then precipitate it. So you have this massive amount of storage, chemical feed pump, and you inject a chemical into the water. It grows the colloid, or it binds it up and it settles it out, and then you filter it. What a pain in the butt that is. Huge.
And that's been replaced by an 8x44 mineral tank
with a backwash head on it. That is the miracle. The ultrafilter is, we replace all that equipment with one backwashing filter plus a clean water tank, which stores the clean water to backwash the ultrafilter. So you have that and another auxiliary pressure tank after it for the worst ones.
Yeah, or you twin them up and let them clean each other.
Let them clean each other. Use two. Yes, exactly. Yep. That's the best way to do it. We've applied them on lake water. We think it will remove the blue-green algae, but we use chlorine, carbon, ultrafilter in these big lakes. That blue-green algae was a big situation.
Yeah. Ultrafiltration will remove the actual algae. The issue becomes the cells can burst in extreme pressure environments. And then the ultrafiltration, we go from a suspended contaminant. When the cell bursts, the cell releases more of a dissolved contaminant that is too small to be trapped by the ultrafiltration membrane. Yeah, blue-green algae is a whole other subject. But yeah, if you're dealing with blue-green algae, you don't want to ever rely on one technology.
Right.
You want redundancy of technology and multiple technologies.
Yeah, that's what we tell them,
Yep.
But lake water in a whole, without that, people were worried about giardia. So you eliminate your chlorine, you eliminate your big storage tank, you eliminate a lot of that, where you could just use a pre-filter, ultrafilter, and a UV polisher. I just say use the UV as a polisher, a small little guy there.
Well, yeah, when you're dealing with stuff that makes you sick, when it comes to water treatment in general, redundancy is always our friend.
Right.
Redundancy is always our friend when it comes to things that can kill us.
Yeah.
That brings me to another point about ultrafiltration in general. It's important to remember that we're removing things like bacteria. What that translates into is, in my professional opinion, you should always regenerate any ultrafilter. I don't care whose ultrafilter it is. If you have a self-cleaning ultrafiltration membrane, you need to clean it with ultrafiltered water. Because we're talking about things that we can't see, and if you regenerate something like an Ultra Pro, and you're removing bacteria, and you regenerate it with bacteria-laden water, where is that bacteria now? It's on the treated side of your membrane, right? So all of a sudden, you can potentially, functionally, completely eliminate the benefit of your ultrafilter. So regeneration of an ultrafilter membrane, any ultrafilter membrane, should always be done with ultra-filtered, or at least water that is properly disinfected by some other means, every time.
So these things can be used kind of like, I like to say, Legos. We can snap two of them together. They're just by an alternating valve between them. And then one will backwash the other with the other. So you twin them up. Real extreme situations, you can quad them up.
We've actually done 6 of them in parallel before.
Yeah, it's pretty neat. So what I started out with was the packaging of these Ultra Pros is quite unique and user-friendly.
And speaking of uniqueness, one really big thing that separates our specific use of this product separates us from literally every single other product that has a clack valve mounted on it. And we use a clack wetted end with custom circuitry. We're the only clack OEM that can drive 4 drive motors with a single circuit board. Just like we designed our membrane system from the ground up with practical use in mind, our current version of our circuit board, we had ultrafiltration specifically in mind. Why? Because we learned very rapidly in pilot testing that the bottom of the membrane, if all you do is just backwash up and out, like a normal filter where your water comes into the membrane, goes outside and goes up and out your clack drain valve or your fleck drain elbow, just like a normal backwashing filter, like a backwashing calcite filter, the bottom of your membrane is going to foul. About the bottom third of your membrane is going to foul. I've witnessed it happen time and time again. When we encountered that, we realized we need to make sure that we can have an automatic flushing mechanism on the bottom of every single ultrafilter. And that's what we do. Every single Ultra Pro has an automatic flushing mechanism built into it. We're the only people that can do, say, a single tank system with separate source regeneration using a clack 3-way valve, a normally open alternating two-way valve on the outlet to make sure that you don't rob any of your regeneration water if your storage tank calls for water. And on top of that, we can still automatically flush. And just like we were talking earlier about soda ash and maintenance issues, yeah, you can say, well, can't someone just go down and open a ball valve every once in a while?
Yeah.
Yes, you can do that. But let's be real here. What's the probability of someone doing that indefinitely?
0.
They're going to eventually stop doing that. And then all of a sudden, your flow rate is going to be cut by a third. And that could happen in a matter of weeks or a matter of months. So it's really important in terms of, once again, focusing on the package. We have a unique package because of our circuit board functionality that allows us to do certain things with ultrafiltration, especially the specific membrane we use that literally no other clack OEM can do.
Yeah,
and I think we can all agree that most of us love the clack valve. So
yeah, it's
pretty special.
A huge, yeah, they're pretty special and sometimes hard to get because it's that good and that design friendly to the things we can do with it on the base valve. So is there anything, okay, this thing is great, everybody's excited and they've been around, but there are limitations. And what have you seen? I know the first thing that kills a membrane is when the timer, the backwashing mechanism fails, or there's a circuit board gets fried from an electrical spike or whatever. The lack of backwashing basically is a membrane slayer, the killer. But other than that, what else is not, you wouldn't apply it to? The do's and don'ts.
The first don't is don't feed it greases and oils. Greases and oils love to foul the membrane. We've had multiple applications on where the ultrafilter is used as a polisher in gray water reclamation in car washes. That's one of the more popular applications. And obviously, we're talking about washing cars.
Undercarriage,
there's going to be a lot of grease and oil involved.
Horrible,
So really, if you're going to use ultrafiltration as a polisher and you have grease and oils, you need an oil separator before the ultrafilter. That is going to kill the membrane. That is one pretty definitive no-no. The other one is make sure you pre-treat appropriately. You want at least a 10 micron pre-filter before this. I relate it to, it'd be like, to make it more relatable, you wouldn't remove gritty sediment with a 0.1 micron cartridge filter, right? Because that's going to plug up in probably like 20 minutes.
Right.
You use a 50 or 100 micron cartridge. Well, same thing, but we're talking about a sub-micron level. So will an Ultra Pro remove ferric hydroxide? Yes. Should you use it to remove ferric hydroxide? No. Use something like Turbidex or Filterag Plus, whatever you want to call it, or a multimedia blend. Use a cheaper...
Get rid of the rocks and boulders.
Yeah, get rid of the rocks and boulders. That's perfect. Get rid of the rocks and boulders before the ultrafilter. Now, with that said, sometimes things get a little tricky. I'll go back to compromise. We always compromise in residential water treatment. Sometimes you may have a situation where ideally the ultrafiltration should really go after everything except for a UV. That's the only thing I would say consistently you would want. If you have a UV, you would want that after the ultrafilter to be your final polisher for bacteria. Otherwise, you generally want to feed the ultrafilter as clean of water as possible. Because once again, we're talking about our ultrafilter membrane is 0.02 micron absolute, 0.01 nominal. That's a really tight filter. So obviously, the cleaner water you feed it, the longer it's going to last, the happier it's going to be, the less pressure loss you're going to have. But with that said, say you have an ion exchange system, and you have water with 200 NTU turbidity, and it's all clay. You wouldn't want to feed that into your water softener, right?
No.
It's going to kill your water softener. So sometimes the line of defense may be a Turbidex filter. Then you feed the trash water that comes out of that. That goes into the ultrafilter. Then you go into your water softener, even if you do have some iron in the water. So it's always subjective, but if it's possible, if the application allows, you want the ultrafilter as far down the treatment train as possible. But once again, it's all subjective to the specific application.
Exactly.
And another common thing is you don't want too much disinfectant. You don't want too much oxidant in the water because once again, not all membranes are the same. Some membranes are more tolerant to chlorine, but less tolerant to high pHs. And some, like our membrane is not as tolerant of chlorine as some of the alternative membrane materials, but we are much more tolerant. We can clean at a higher pH more consistently.
Okay.
So once again, it sort of comes down to the details of the application. For example, we use a lot of Ultra Pros in the Pacific Northwest for organics reduction.
Yeah.
Well, if you're using organics, you're not trying to clean off organics with chlorine, right? You're trying to clean off organics with something like a hydroxide solution. So in that scenario, our membrane makes more sense than the alternative. And our membrane can tolerate chlorine, but our general recommendation is you want the continuous feed level of chlorine to be below 1 milligram per liter. As long as your chlorine is less than 1 milligram per liter going into the Ultra Pro,
right,
it shouldn't be an issue. But above that, you do need to consider it. And if you are occasionally disinfecting the Ultra Pro with chlorine, sometimes in a conventional filter, like say something like Pyrolox,
right.
I'm sure I've told people, I'm sure you've told people, oh, you get an odor back, your sulfur odor is creeping back, and I just throw a half a cup of bleach in there.
Yeah.
Well, that's a ridiculous concentration of chlorine. We don't actually need nearly that much,
right,
but it's all going to drain, and it's a once in a blue moon thing, so who cares?
It'll burn it up, yeah.
With ultrafiltration, it's a little different. Because if you're disinfecting an ultrafilter, you probably have to do it on a fairly regular basis. And if you hit it with an excessive dose of chlorine, all you're doing is you're going to prematurely dry out your membrane.
Right.
So it's not that it can't see chlorine. It's that you need to pay more attention to how you feed it chlorine, because the chlorine is going to slowly degrade the membrane.
Right.
So it's something you need to keep in mind. But in terms of continuous feed, so on a city water application, as long as the chlorine is below 1 milligram per liter, I honestly wouldn't worry about it.
It's just like, I really like fried chicken. If I eat it every 6 months, I pay, but it's not really going to kill me. But if I eat fried chicken every day, pretty much it's going to fry my membrane. So, I don't.
I'm the same way with pizza. If I could eat pizza every meal of every single day.
Of course.
But if I eat pizza 3 days in a row, even just a couple of slices, I
go cross-eyed. Yeah,
I do not have a pleasant evening. I'll put it that way.
No, it's but yeah. So that's just like any rule in life. But yeah, it's more pH tolerant than the oxidizing chlorine.
Yeah, it's very pH tolerant.
How about hydrogen peroxide? A lot of guys use that.
Hydrogen peroxide, so that's actually something that I can't give you a definitive answer on that.
It's liquid oxygen, really.
Yeah, looking at the material construction of the membrane, I would follow the same rules as chlorine.
Yeah.
Is what I would do for that, because we're talking about a strong oxidant. I generally don't like using hydrogen peroxide to disinfect the membrane.
Yeah,
simply
not good,
because you hit it on the point. It's basically oxygen.
Yeah.
It's oxygen that has been restructured in a certain way. What that means is hydrogen peroxide rapidly dissociates to oxygen. And what does bacteria really like?
Yeah, it's oxygen. Right. So that's what I tell everybody. Yeah.
Unless you literally kill everything, which you never kill everything.
No.
The stuff that's left, I relate it to the pesticide treadmill. Pesticide treadmill is the concept of you kill the pest with a pesticide, and the only stuff that survives is the strong stuff. And then evolution does its thing, and all of a sudden, the only pests you have are the stuff that are resistant to your pesticide.
Right.
We can sort of apply that same logic to something like disinfection of a membrane. We can hit it with hydrogen peroxide. Are we going to kill most of the stuff? Yeah. But the stuff that does survive is probably going to be the strong stuff, or the stuff that's hiding in an already formed biofilm.
Right.
And then, but the bad thing about hydrogen peroxide is that then not only is there a little bit left, which is going to be a little bit left with chlorine too, but then with hydrogen peroxide, we feed the stuff that's left, we feed the strong stuff oxygen. Mm-hmm. So we make the strong stuff even stronger, and then that stuff comes back even stronger than it did last time.
And then our membranes all fouled out.
Exactly.
So, well, we're running out of time here, but is there any other hard and fast rule other than what we talked about?
Pilot test.
Pilot.
Always pilot test.
Yeah, we have the pilot stick.
Yep, it's a
mini
little
membrane.
It is the exact same membrane as what is in the Ultra Pro tank, just a whole lot less of it. So whatever that stick, whatever the UF pilot stick, as we call it, takes out, that membrane is going to take out. It is the exact same membrane, just a whole lot less. It's a little stick.
Yeah, it's
with
spend
half-inch
$100,
fittings.
not the $2,000.
Yeah,
you know?
exactly.
Yeah, don't do your experiment.
It's got half-inch threaded connections. It only flows about 0.2 to 0.25 gallons a minute, but it's meant pretty much just for pilot testing. And it's obviously trickier to pilot test a bacterial application. But if you have a colloidal clay or especially a tannin application, because tannin is a very big term.
It's a mess,
You know, the micron range or the molecular weight, to speak correctly, range on what we commonly sort of falsely call tannin in the industry is huge. So big that sometimes you can take out tannin with a 18 by 40 mesh carbon filter. Sometimes you need an organic scavenging resin. Sometimes you can take it out with ultrafiltration. I've had multiple jobs where we have to go through carbon to take out the big stuff. Then we go through ultrafiltration to take out the medium stuff. And then we polish with organic scavenger, because if we feed just straight into the organic scavenger, it gets overloaded.
So that pilot stick, great tool. Now, the thing is, it's a little guy and it's a little pilot stick. You put hose connections on it so you can use it as a test mule. But I get this all the time. How do we store that little guy, and can we backwash flush it just to keep it for the next time? It's a tool and a tool. It's truly a tool in your toolbox. So
that's an essential point to hit on too, is because when you look at pilot testing, we're not just concerned with, can we take this stuff out? We're also concerned with, can we practically get this stuff off the membrane? So back flushing it is as simply as flipping it around. Flip it around and flow water backwards through it. That's going to mimic backwashing an Ultra Pro, a full-size Ultra Pro system. In my experience, if you can get at least a liter of water through the stick without excessive pressure loss occurring, and then if you can clean it relatively easily with just clean tap water, those are the starting metrics I use for pilot testing. When that doesn't work, that's when you start trying, okay, well, maybe we hit it with some chemicals to clean the membrane, so on and so forth. But pilot testing is really a two-part question. Can I take it out? And can I clean it?
Yeah, good.
And cleaning and then as far as storing it,
refrigerator?
No, don't refrigerate it. What I would recommend doing is, if you're not going to use it for a while, if you're going to use it once and then you're not going to use it for like a year or something like that, you want to get some glycerin in the membrane. The glycerin will act as a preservative for the membrane. That's probably the safest.
Where do we buy glycerin? At the glycerin store? You know, we go down to 7-Eleven.
You would be shocked at how many baked goods have glycerin in them. You should be able to buy glycerin in the baking section of a grocery store.
Really? There's food for thought.
Yep. Look, I encourage you to look at a big box store cake recipe, and you will almost definitely see glycerin. So,
man, the things we don't want to know.
It's I probably just ruined cake for a lot of people.
Cake. So wait a minute.
That's why it's so moist.
Yeah. Glycerin.
So,
who knew?
Yeah, if it's going to be a really long time, use some glycerin. If you're going to be using it like we use ours probably once every couple of weeks here, and what we do is we just put a dilute chlorine solution in it,
very light,
like half a part, something like that, just to help inhibit microbial growth.
Right.
But you don't want to do that and let the chlorine sit in there for months on end.
Right.
If you're using it regularly, just freaking cap it.
Okay. Yeah. Just cap it and just throw it. Yeah.
And I would occasionally, I would say, even with regular use, at least once a month, I would just flow
water through it.
Well, I would flow half a part per million of chlorine.
A little bit of chlorine, and don't put it on your dashboard of your truck in Florida.
Yeah. Heat is always a no. Bacteria likes heat.
But this
it's all about preventing biofilm.
Again, we digress a little, but this is just the pilot stick. You know, the main. This is a little testing mule that you can buy to use in the field before you spend all the big money for an ultrafilter. Use your little pilot stick, and it's a great point. So,
and we will also do pilot testing at our facility for you.
Oh, okay.
If you want
a sample.
Yeah, we require absolute minimum 1 liter of water.
Okay.
And I would just emphasize, please, and this is, once again, good advice across the board for water treatment. Please don't put water analysis samples in things like soda bottles or
Iced tea.
Yeah, or iced tea.
Pickle jars.
Yeah.
Yeah.
Please just like
Good spring water.
Yeah, go to the grocery store, buy a 89-cent gallon jug of spring water, dump it out, or preferably drink it.
Yeah.
And then use that.
Use the spring water. Yeah, the clear.
The frequency with which I get water samples where and by the way, remember, most of the things that make our food and beverages smell linger.
Yeah.
So if you think you're fooling a lab tech by drawing a sample in a Coke bottle and then pouring it into a sample bottle, I can assure you that lab tech is going to smell that sample and say, I'm not testing this. Yeah. This smells like Coke.
Well, good. Hey, we're up on our time here. Thank you, Justin Mest, Water Conditioning, for this ultrafiltration on the pH and ultrafiltration. We really, really appreciate it. I'm Mike Urbans with Urbans Aqua, and this is your water.